Okay. It's not all.
It's fine. Everything else was activated. Probably not.
All right, Joel, if you just got here, there, the next one that we're on is example 10. And these guys said, let us just do it. So try to do that one yourself. David. Yeah.
What does it mean on the poster when the aspects come with like X, whatever that is?
Oh. It's basically the radius of, or the interval of conversion. And the last ones say that X can be any number in the real numbers, any real number, meaning the interval is infinite. Yeah, that's cool. I never noticed.
I don't know if this was concerned.
Oh, nice. Good job. Yeah, if you needed a hint, there it is. This is when you're finding any sort of power series, you can always like resort to this, plug in numbers until you see a pattern. And then hopefully you saw, I don't know how far you guys got. Do you want more time or should I start? All right, well, let me just start then. Hopefully you saw that the pattern goes 1, 0, negative 1, 0, and then it'll start over again because you're back to cosine. So 1, 0, negative 1, 0, 1, 0, negative 1, 0. So the theory would look something like cosine of x equals 1 plus 0x to the first over 1 factorial minus 1 x squared over 2 factorial plus 0x cubed over 3 factorial minus 1 0 minus 1 plus 1, sorry, x to the fourth over 4 factorial plus 0, etc. Actually, let me just do dots here. There you go. And then the nth term should look like, I don't have much room, so let me do it down here. The nth term, I guess, kind of depends on the, actually, let me not even do it like that, because it kind of depends on which derivative you're on, like what cycle of the derivative you're on. I can't generalize it here, but you can generalize it if you cancel out all the zeros. It looks like 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, which I think you guys remember because we discussed this 6 over 6 factorial, etc. And this one you can generalize because there's a very clear pattern. First of all, it's alternating. Boop, 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 boop. So hopefully you remember that means negative 1 to the n. Or is it n plus 1? No, normal n because the 0 with 1 was positive. Okay, so alternating done. Then it's only the even one, so that should be x to the, do you guys remember how to write just even ones? Nice. Yeah, it's just multiples of 2, so 2n And then over the factorial should match the power. So that would be 2n factorial, like this. Nice. And I think this would be, I mean, this is a fine way to write it if you put another plus dot 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 to like to indicate that you're going to infinity, or you can put it in sigma notation.
Wait. The one wouldn't exist then. Personally. It's just 2n.
But 2 times 0.
But wouldn't that be the sign then?
No, watch
Next
it. Watch it. You start at the 0th derivative, then that should all work out because then x to the n over 2n factorial. The 0th one here is in green. The 0th one will be -1 to the 0 times x to the 0, 2 times 0 over 0 factorial. And -1 to the 0 is 1. X to the 0 is 1. And 0 factorial is 1. It's just defined to be 1 just for convenience, basically. But there's also this mathematical like argument for it that might be interesting to talk about if you're interested. But anyway, 1 times 1 over 1, that's this one right here. So it's all good.
Wait, isn't that the sign one? Negative. The negative sign.
No, I see what you're saying now. There's my answer, by the way. No, because every other one was a 0. So it's kind of we're only writing every third one because the middle one will be 0. This is kind of like, oh wait, I can just disregard these and I still see a pattern between them. So actually this -1 whatever is this negative cosine right here. It's the second one. Because the sine one was the 0. Yeah, good job. Good point. Yeah, yeah.
When you're writing like 2n factorial, do you have to have 2n in parentheses, like instead of like m dot?
Yes, nice. Yeah, question for the video was when you're writing 2n factorial, can you write it like 2n factorial? And no, because that kind of looks like that. So that would be wrong. That would be a no. Put the 2n in parentheses. Nice, you all good questions. Other thing? Okay, well then next one is similar, I think. It's about sine. Yeah, you guys should do that one. Hopefully, you guys ready or need more time? Guess what? Okay, watch this. All right, watch this. If you did the same thing, f of 0, f prime of 0, double prime of 0, etc., then you'd find a similar pattern. So let me not waste your time like going through these. This would be, I guess, sine of 0, 0, cosine of 0, 1, and so on. And so then you find, I think, a similar pattern shifted by 1. So it's 0 plus 1x to the first over 1 factorial, I guess. Plus 0x squared over 2 factorial. It's now all the odd ones that you get. So you guys got that? And so then if you ignore all the zeros, you get this pattern, x minus x cubed over 3 factorial plus x to the 5th over 5 factorial plus minus x to the 7th, so on. So that the general term is still alternating. So that your series is going to look really similar to the last one. But let me make sure you guys got it. What did you put for the exponent of the alternating bit? Yeah, still that one is n because you still start positive. So when you plug in 0, you need it to be positive. Well, depending on how you set this one. But x to the odd power, do you guys remember how to write that? Nice. 2n is even, so add 1 to make it odd. Now those are always odd. And if you did 2n minus 1, then you would have had to start your sum at 1 instead of 0. But I think it's more normal just to, yeah, look at the poster also has it as starting at 0, so do 2n plus 1. And then, of course, if that was 2n plus 1, then your factorial should do it. Good job, y'all. And then plus blah, blah, blah. Or, again, sigma notation, write that next to a sigma. N equals 0 to infinity. And 1 to the n, that's the 2n plus 1. 5 plus 1, that's over. Boom. Nice. Questions on this? Okay, very nice. The next one, you're going to think, oh, shoot, a whole new oh, wait. I forgot about this. But here's the 4 series that you should know off the top of your head, ideally, or if not, in the middle of the test, you could figure them out real quick. E, cosine, and sine, you guys just saw is pretty easy to get by yourself. This one might be annoying to get by yourself, so that one might be good to just memorize. That this geometric series x to the n is equal to 1 over 1 minus x. Okay, so know those because look at these next one. It says find the Maclaurin series for sine of x squared, and then find the first 4 non-zero terms and the general term. Okay, so if you just saw this at the beginning of class, then your first instinct might have been to do 0, f prime of 0, f double prime of 0, etc. But, and that would work, and good job, this would get you the answer eventually. But do you see, look at, let me do, f of 0 would be sine of 0 squared, I guess, which is sine of 0, so that's 0. Okay, no problem so far. But then the more derivatives you take, watch this. Derivative of this would be, you tell me actually. Oops. Yeah, it's a chain rule. You got a cosine or a sine and an x squared, so it'd be 2x for the derivative of the inside times cosine of x squared. Okay, not that big of a deal. You plug in 0, you still get 0 and 0. Well, 0 times anything is 0. But then now take another derivative to try to find a pattern, and you have this product rule that you have to do first times derivative of the second plus second times derivative of the first, within the derivative of the second, you have a chain rule, so you're gonna be doing more of this. And that's, they want you to find the first four non-zero terms. We've already done a couple that are zeros, so those don't even count. And you'd have to keep going, keep going, keep going. So this would be very, very annoying to do by like the long way, although it would get you the right answer. But do you guys see a shortcut you could take?
When you're multiplying by like an X, but always have to be zero. If you're plugging in zero, add that.
Oh, I see. Like you could skip all of these bits.
I mean, yeah, because you're multiplying by it.
I see an even quicker shortcut, but yeah, you're right. That would help you out. Do you see the shortcut? What do you mean? What do you mean?
Like, put it in, like, you have to use it, I don't know.
I mean, basically, yes, that's what I'm about to be getting at. Is that this is sine of something? I know this the series for sine of x is the one we just got, but the second ago.
Or,
Hang on that for 1 sec. Here's sine of normal x, and then Annika said, well, instead of sine of x, I need sine of x squared, so just make that an x squared. Again, this always feels like cheating, like, no, that shouldn't work, but it does work. What? Yeah, that's all, this is good. Because, I mean, sine of, it doesn't matter what you put in here, sine of smiley face would just be the sum of blah, 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 -1, blah, 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 smiley face to the 2n plus 1 over 2n plus 1 factorial. Like, it doesn't matter what the argument is, especially because this will converge for any x. Like, sine of x converges for any x. So how quickly this inside can just, like whatever's inside the argument for sine will be inside the argument for the series, because they're equivalent, they're equal to each other. If this side equals this side. That's true. That's the truth. Yeah, it's different having sine of x squared, where you can just replace the x for an x squared, than having sine squared of x, which is like sine times itself, in which case you would have to do like this series times itself, which is not nice. Like that would take a little bit out of you. So no, that would be, but they wouldn't ask you that. But that would be ugly. The question was, what if it was sine squared? And that's what I was just talking about. Then there was the second question, could you leave the answer as this sum times this sum? And the answer is usually no, that would be too, like it doesn't, that's too hard to decipher what's going on with that. Like sum times sum doesn't really give you an idea of what the result would be. So you might have to multiply out a few terms or do it this long way if it was sine squared and find a pattern. Cool. So anyway, here is my sum. Let me take this question, and then we still have to find the first 4 non-zero terms and the general. Well, the general term. Yeah.
Wait, so is this true for all the other elementary theories? Where like,
Yeah.
if it's e to the x plus something or whatever, you can still plug it in.
Yes. Good job. Yeah. The question for the video again was, can you do this for any of the series? Like, can I do this for e to the x to the 5th? And yes, you could. You could just replace the x, or like even e to the 2x or something like that. 2x plus 1. Something like that. You just replace the x with whatever replaced the x in the original function. Nice, y'all. All right. Like I was saying, this was asking you for the Maclaurin series, done, and now find the first 4 non-zero terms. So let's do that. And then the general term just means this. What I'm about to highlight, like this term with the n, that is the general term. So I don't know if they want you to rewrite it. Or if they just mean putting it in the sigma. But either way, here's the first 4 non-zero terms. I plug in 0 into the function or into the series, and I would get +1. Oh boy, okay. +1 for the alternating bit. X squared to the first over 1 factorial. So if you can keep track of all that in your brain, that will just be x squared. Well, okay, let me go off to the side. -1 to the 0 times x squared to the 2 times 0 plus 1 over 2 times 0 plus 1 factorial. So what I'm saying is this part is +1. This part is 0 plus 1 is x squared to the first, which is just x squared, of course, and then over 0 plus 1 factorial. Or in other words, that's just x squared. Cool. Then you got your first one. And the good news is, okay, if I know the first one is positive, then guess what the next one's going to be? Yeah, for sure, because this is alternating. So next one will be negative. I can ignore this part. Then if I plug in a 1, which would be the next term, I plugged in 0, now here's me plugging in 1. I would get x squared. So let me do that off to the side. X squared to the 2 times 1 plus 1 over 2 times 1 plus 1. Or, I guess you could do it a shorter way, but here's us. If you didn't notice that, here's us doing it this long way. X squared. Oh, yeah, you're right. This would be negative that.
Yeah.
Negative that. But x squared to the third over 3 factorial. This would simplify to be x to the negative x to the 6 over 3 factorial. Yeah. So x to the 6 over 3 factorial. The shorter way I was going to say is that these are all the odd ones. The powers of x squared are going to be all the odd ones. So you can figure it out that way. So the next one will be plus x squared to the 5th now would be x to the 10th over 5 factorial. And then you can kind of see the pattern is x squared, this is 4 bigger, the 6 is, and then 10 is 4 bigger than that. So the next one would be minus x to the 14 over 7 factorial. Or 7. Nice. There's the first 4 non-zero term. Wow. Nice. And you can see this would have been annoying to do the long way. You would have had to do 4 derivatives in between each of the non-zero terms. It would have been annoying. All right, and then the general term would be this, so you could just write plus dot 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 plus. Here's us just making sure if they wanted us to rewrite it again, we did it. Here's the general term they're talking about. Plus dot dot dot. Yeah, you.
Wait, is it like to rewrite what I'm doing like an x squared to the power of 2n plus 1 is 4n plus 2?
Yeah.
Squared to the power.
Yeah. You could combine these, and it might even look nicer and cleaner. Yeah.
It makes it a lot easier to write.
That's the truth. Yeah, that's the truth. If you wanted to simplify this from the start and do less thinking later, this would have been like you could have multiplied those and gotten 4x to the 4 and plus 2, and then there's less thinking that you have to do later when you're finding the first 4. Nice. Other questions? All right. Now it says find the Maclaurin series for x times cosine and the first 4 terms.
Right.
So again, use the same shortcut as before. So see if you remember. If you remember the cosines. In fact, just try this whole thing. And if you're feeling anxious about, can I just multiply that series by x? The answer is yes. Okay. Like if that's what's stopping you from making progress. Yeah. Yeah, except you just plug in x squared into this one. Oh, then be careful because this times another x would be x squared. Then it would be x to the 2n plus another one. Like you got 2n x's here multiplied by another one. Now you have 2n plus.
Oh, yeah, okay.
This,
Nine.
you got one.
All
All
right.
right, I guess you might.
Oh yeah, the first four.
Really, so you have to move it to.
No, I just meant you can't multiply a sum times another sum, but that's good. Yeah.
Oh, that's. Literally just multiply by x.
Yeah. All right, all right. As you guys get done, I'll start mine.
It's the way I think of that. It's like, can you put it in front of the sum?
Like out here. Yeah, but it wouldn't be as helpful for a reason that I'm about to say in a second.
Okay.
But yeah, you could. All right. So I think most people got to this point where you said, here's cosine, now multiplied by x. There it is. And then something next you could do is now combine the x to the 2n times the x to the first to make it x to the 2n plus 1. And then not only does that look nicer, but like more succinct and simplified, but also it helps you find the first four non-zero terms in the general term. Say that again. All right. Well, yeah, you're right. That is the general term. Now here's the first four non-zero terms. The plug in zero, I get positive. These will be odd and these will be even. So positive x to the first over 0 factorial, so just normal x. Minus, now this will be x to the third over 2 factorial plus x to the fifth over 3 factorial. Nope, I lied. Over 4 factorial. Minus x to the 7 over 6 factorial. Nice. And then plus the general term if they want to write it here it is again. Nice, y'all. Yes.
So for the first four terms, you have to write the general term, like dot, like to it.
I think that's what they meant.
Okay.
I'm pretty sure that's what they meant. I mean, I haven't seen this exact wording on the AP test, so if it was just me grading this, then if you gave me the sigma and you gave me these first four, then I would be fine with that. But I think what they meant is write it as a sum with the first four terms included, and then do your dot. I think that's what they meant. Yeah.
Because the more question, like you have to then after repeat it plus dot. Because like when I see the answer, I'm feeling like this. I guess it's not like.
Yeah. Yeah, I was just the question for the video was, do you have to do the dot dot dots on either end of the nth term, like this term in general? And the answer is kind of just because of the way I wrote that this series, this infinite series, is equal to what I just wrote. Then yeah, I have to put plus dot 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 to like indicate that I'm going to infinite.
What if
But again, I haven't seen this wording on the AP test. What if you just what?
I was putting a sum at the front of it, indicating that it was going into infinity, plus the sum of the nth term. Could you do it like that? Like I literally just put the sum there.
Then that's kind of tricky because it looks like you need take an infinite number of these sum.
Um,
But it's like one or the other could be double fit. Nice, y'all. All right, and then last little bit. Look at this. Oh, I think it is. Yeah. Okay. Good. Now it says, find out what this adds up to be. And here is you guys looking at this being like, oh, I don't know how to do that. Except here's a hint without me saying anything. None. I don't think. I mean, for my requirements, none. This is my hint, what's on the screen. And I guess another hint is I'm not expecting an answer like 46. Your answer will be probably kind of ugly. Or unsimplified. Nice. Nice. I don't think. No, yeah. Right. Nice. Yes. Not that correct. But instead of the
Oh, you look for the one.
or
Oh, it's, yeah.
okay.
You,
You,
oh, wait.
nice, y'all. I'm seeing a lot of
well,
things.
that's the sum of the series. Of the series. So it would make sense. I had the right idea.
Okay. You guys want more thinking time or you're good? Okay. Yeah, from what I heard and saw, it looked like a lot of people figured it out. So the idea was that if you look at this sum, it should look a lot like one of the elementary sums, but with a specific number plugged in. So this one, the first one, should look a lot like which one of those sums? I forgot those. I forgot the brother. Yeah, this should look like e to the x, except instead of an x, it's a 3. Look at 3 to the n over n factorial, x to the n over s factorial. So instead of the x, that's a 3. So what did you say your answer was? Yeah, e to the third, straight up. Nice. Good job. And then the second one looked like which one? Yeah, -1 to the n, x to the 2n plus 1 over 2n plus 1. The same thing, except that's a 2. So what do you say your sum was? Sine of 2, good job. And then the last one was a geometric one. which adds up to be 1 over 1 minus x. In this case, the x was a negative 2/3. So this would have been 1 over 1 minus negative 2/3. You could leave it like that, or that simplifies to 3/5, right? Okay. Boom. And now you guys finished AP Calculus BC. Yay, we did it, you guys. And we still have 2 weeks to review. But in those 2 weeks, you have to learn. Well, I think you guys are good at the AB stuff, like because we've been reading that. But you got to keep track of all of these things. So let me stop sharing my screen so that people in the video can see it. Stop sharing. Okay, so in unit 6, you learned integration by parts, which is like the product rule one. Integration by partial fraction decomposition, which is this one. You learned improper integrals, and you learned a fourth thing. Do you guys remember it? No.
The series.
That's like,
Wait, is this you?
Ours was unit 8. Yeah, find your unit 6 one.
I think.
No, I know for a fact I did 4 videos.
Wait, it was.
Oh.
It's only 3 in the past.
Okay, sweet, nice. Okay, then I did a good job. These are the 3 from unit 6. Unit 7, you have to learn Euler's method.
I'm like just staring at ours, like,
Yeah.
right?
Yeah, this is one where you have to do like a bunch of tangent lines and do a bunch of
Oh, yeah.
combinations that way. So not super hard, but very tedious. Don't forget it though, because I see it every year on the AP test. And sometimes multiple times, like they really like it for some reason. Well, I guess it's very helpful and probably useful in higher math or like in applied math. I took a bunch of pure math classes. Anyway, Euler's method was unit 7 and logistic models, which are the ones that look like this. The graph looks like that. And the differential equation for that looks like. That. If you don't remember that, go back and review it. The questions they normally ask on the AP test are like, which one of these is logistic? And you just have to look for this key thing. They're not super hard, but I mean, it's 3 points if you remember it. That's unit 7. What time is it? Okay, sweet. Unit 8, the only other.
Is there anything other than other thing?
No, I don't think so. I think unit 8, yeah, was only arc length, which remember was yeah, basically you're thinking distance formula. And then of course I can't go. Unit 8 and unit 9 was like 12 things altogether, like 9.1 to 9.4 plus 10.1 to 10.8. That's 12 things that I don't want to list out, but you guys have the packets for. All of unit 9 and all of unit 10. Those are the things to keep track of. Yeah, I mean, that's, yeah, for sure. If you're thinking test taking strategies, unit 10 is huge on the test. So it's good to like, at the very least, do your homework. Or there's like 1,000 problems on your homework. So choose the odd ones or choose one per section or something. But do some yourself. It's way different having me up here explaining it and you're like, yeah, I get it, than when you go home and try to do it yourself. So try that. And then, like I said, I'll keep coming in every day. Even Wednesdays, maybe I'll come in when I don't have meetings. Sometimes, I mean, I have 2 meetings a month, so I won't. I got to check when they are. But when they're not, I'll come in for Wednesday. Friday, I'm out. Yeah, I'll figure out, but I can't come in tomorrow, I think, because I'd have to come in here, drive an hour back in the traffic, drive an hour past to get my wife to the airport and back home. So yeah, that would be 4 hours in the car for a quick review. So maybe I'll make a video or something. I'll let you know. I'll post on Schoology or something. But that's what I'll do. And then next week I'll be here probably every day unless there's a meeting. There's a lot of questions. Sorry, question. It wouldn't convert. I don't know why it excludes that, but like that would look like a times 1 to the n. So like it would be like, and the very simplest one would be 1 plus 1 plus 1 plus 1 plus 1 plus 1. So it would divert. Yes.
Okay, per integration by partial fraction decomposition, is that one? Oh, if I were to maybe not do one of them, because it's really complicated, like how much is that on the AP then?
I might be like 1 or 2 on there.
I couldn't understand.
It's kind of fun and not super hard.
I have a question about like percentages, like what, units, like unit percentages on the APs, is it all like the same? 40%?
It takes so long.
Okay, even if
That's like
that, that everything else is good.
I don't read my messages, but the question was about. Oh yeah.
No, actually, it's not. All of it? You did?
The question was about percentages, and here they are.
Okay.
Okay.
Yeah,
He's gonna provide what you think. Yeah.
All right, y'all. Good job.
Bulletins.